Hi, my name is Peter Allen. I'm a professor of computer science at Columbia University. I also live in Pleasant. I'd like to welcome you to our robotics lab. We're building some very cool robots. This is one of them, which is called the PR2. It's a two-armed robot, has a mobile base, moves around, an assistive helper for many people. Over here, we have a very small arm that goes on the side of a wheelchair and assists people who need help picking things up and they can't do it themselves. We have some other robots as you look around the room, and we'll talk more about those later on. But first, I'd like to talk to you a little bit about my own experience with STEM and as a math major. I was a math major in college and didn't touch a computer or a robot at all. In fact, I found math very dry and boring. I didn't see how I could connect to anything real in the physical world as it was so abstractly taught. I never thought I would use all the math that I learned. When I graduated college, my first job was driving a cab. But unfortunately, I got robbed at gunpoint, so I looked for a different career path. I worked for 6 months at a computer company that taught me to program. And I got hooked on computers. I then spent 3 years teaching junior and senior high math and computer science and realized I needed more formal training in computer science. I went to grad school and luckily met a professor who was at the forefront of the emerging field of robotics. She showed me how much fun and creativity were involved in building intelligent machines. And lo and behold, all the math I thought I would never have used became an everyday tool in my research. I finally understood that science and math together can create exciting new technologies and also allow one to show off their creative side. So now I get to design, build, and play with robots every day, and it is a dream job. So now let me show you some projects we're working on.
Well, picking up your clothes and folding them, we've all had our mothers tell us to do this, but we have robots that can do this now. So here we have a garment that we're picking up, and we just picked it up randomly, and we can create a 3D volumetric reconstruction of this garment using a Kinect range sensor. And now, once we have the model, we can find out what kind of a garment it is because we have a database, and we can align that garment with our database model and find out exactly how we're holding up this garment. Once we have that, then we have to figure out how to regrasp it so we can lay it flat. And this tells us that given where we've picked it up, where the most optimal place to find for the next grasping point is, and the robot will find that out. This is a Baxter two-armed robot we're using. And it finds the grasping point, and now it can lay it out. We need two-arm trajectory movement here that's coordinated, and we can lay it flat where later we can fold it. We're also creating robots that do surgery through one hole. This is called single port surgery. In the one small incision, we insert this device, and now you can see inside the body what's happening. It opens up like a flower. There's a camera system with stereo cameras and two snake-like robot arms that can come in and actually do surgery and do grasping, suturing, whatever's needed. This is the CAD design that we started with. This is another view of it, and you can see the number of degrees of freedom, how much dexterity this robot has for doing surgical tasks. Once we can do the design, then we have to fabricate and build prototypes. This is the prototype of the robot, here doing some training tasks with the surgeon, moving these discs from pole to pole. You can again see the dexterity of the robot. One of the exciting things is to take these prototypes and have them used in the real world. We've actually sold this device to a company, and this is the version that is being used in an animal experiment here, and hopefully will be in hospitals soon. And again, this is a breakthrough in robotic surgery, allowing surgeons to have much more dexterity with a low-cost, simple device. It's not all hardware, we also do software, and you can see here we have tracking algorithms which can track the location and position of these two robot surgical arms during a procedure. This allows the surgeon not to worry about where the camera is, but lets the system decide where the camera should go automatically. You can see the fidelity and the speed with which these tracking algorithms work. The red is what we think where the arms are, but it's really wrong, and the blue is found by using our vision algorithms. So I hope you found these robots exciting, and you can see how much fun STEM can be.